Good day everyone. This discussion is all about fire protection Kidde system. Large commercial aircraft almost exclusively use continuous thermal sensing elements for power plant protection. Since these systems offer superior detection, performance, and coverage, and they have the proven ruggedness to survive in the harsh environment of modern turbofan engines. These are the parts of continuous loop fire detection system element.
Continuous loop system, the negative and positive coefficient of resistance. In fire detection, if the temperature increase, the resistant insulator material will decrease. This called the current flow center electrode altitude increase until the temperature, the coefficient flow, and the warning light will apply. If the temperature drop back, the warning light will stop.
Kidde system. In the Kidde continuous loop system, two wires are embedded in a conduit tube filled with thermistor core material. Two electrical conductors go through the length of the core. One conductor has a ground connection to the tube, and the other conductor connects to the fire detection control unit. When heated, the transmitter material drops in resistance. As the temperature of the core increases, electrical resistance to ground decreases. The fire detection control unit monitors this resistance. If the resistance decreases to the overheat set point, an overheat indication occurs in flight deck. Typically, a 10-second time delay is incorporated for the overheat indication. If the resistance decreases more to the fire set point, a fire warning occurs. When the fire or overheat condition is gone, the resistance of the core material increases to the set point and the flight deck indications go away. The Kidde continuous loop system can supply nasal temperature data to the airplane condition monitoring function of the aircraft in flight monitoring system, AIMS. The rate of change of resistance identifies an electrical short or a fire. The resistance decreases more quickly with an electrical short than with a fire.
Sensing element. The resistance of a sensor varies inversely as it is heated. As sensor temperature is increased, its resistance decreases. Each sensor is composed of two wires embedded in thermistor material that is encased in a heavy wall inconel tube for high strength at elevated temperatures. The electrical connectors at each end of the sensor are ceramic insulated. The inconel tubes are shrouded in perforated stainless steel tube and supported by Teflon impregnated asbestos bushings at intervals. The shroud protects the sensor from breakage due to vibration, abrasion against airplane structure, and damage from maintenance activity. Combination fire and overheat warning. The analog signal from the thermistor sensing element permits the control circuits to be arranged to give a two-level response from the same sensing element loop. The first is an overheat warning at temperature level below the fire warning, indicating a general engine compartment temperature rise, which could be caused by leakage of hot bleed air or combustion gas into the engine compartment. It could be an early warning of fire and would alert the crew to appropriate action to reduce the engine compartment temperature. The second level response would be at a level above that attainable by leaking hot gas and would be the fire warning. Temperature trend indication. The analog signal produced by the sensing element loop, as its temperature changes can readily be converted to signal suitable for meter or cathode ray tube display to indicate engine bay temperature increases from normal. System test. The integrity of the continuous loop fire detection system may be tested by activating a test switch in the flight deck that switches one end of the sensing element loop from its control circuit to a test circuit built into the control unit, which simulates the sensing element. Dual loop system. Dual loop systems are in essence two complete basic fire detection systems with their output signals connected so that the both must signal to result in a fire warning. This arrangement, called AND logic, results in greatly increased reliability against false fire warnings from any cause. Should one of the two loops be found inoperative at the pre-flight integrity test, a cockpit selector switch disconnects that loop and allows the signal from the other loop alone to activate the fire warning. Automatic self-interrogation. Dual loop systems are automatically perform the loop switching and decision-making function required of flight crew upon appearance of the fault indication in the cockpit. Automatic self-interrogation eliminates the fault indication and assures the immediate appearance of the fire indication should fire occur while at least one loop of the dual loop system is operative.
Support tube mounted sensing elements. When you want to mount the sensing elements on the engine, and in some cases on the aircraft structure, the support tube mounted element solves the problem of providing sufficient element support points and greatly facilitates the removal and reinstallation of the sensing elements for engine or system maintenance. Most modern installations use the support tube concept of mounting sensing elements for better maintainability as well as increased reliability. The sensing element is attached to a prevent stainless steel tube by closely spaced clamps and bushings, where it is supported from vibration damage and protected from pinching and excessive bending. Fire Detection Control Unit. Fire Detection Card. The control unit for the simplest type of system typically contains the necessary electronic resistance, monitoring, and alarm output circuits housed in a hermetically sealed aluminum case and filled with a mounting bracket and circular electrical connector.